Hello, pre-calculus trig students, and welcome back to our lessons on, well, vectors. And today we're learning more about vectors and complex numbers. But before we learn anything new, let's go back and remember the stuff that we did last week and the week before. So take out those notes, and here comes what would have been today's problem of the day. So over here, let's look at this. We're going to find the component form of each vector, find the angle between the two vectors, and also the projection of this red vector onto the blue one. Remember, projection is like making a shadow. Alright, component form of each vector, here we go. So first you need to know the initial point and the terminal point. The initial point here is 2, 1. So there's my 2, 1. And then over here my terminal point is negative 2, 2. In order to form the component form, I'm going to draw my little elbow brackets and put a subtraction sign. You always start wherever the arrow points, so this is negative 2 and then minus 2. Over here, again, you're starting with the arrow points. Let's do the y values. That's 2 minus 1. Sorry. Yes. 2 minus 1. So this is going to give me negative 4, 1 for vector v. That's component form. Let's go with vector u. Vector u, I'm going to draw my elbows and the minus signs just like before. That's my initial point. It's the same initial point, so I don't have to change it. This is the point negative 1, 2, 3, 1, 2, 3, 4, so negative 3, negative 4. Always start wherever the arrow points, so we're starting here at negative 3 and then we're subtracting 2. Then do the y's. We've got negative 4 and we're subtracting 1. So that gives us the vector negative 5, negative 5. That is vector u. Alright, now that we have that information, let's go and find the angle between u and v. First, let's remember back to our cool little formula. This is the cosine of theta equals, on the top we've got the dot product. On the bottom, we have the magnitudes multiplied together. Remember, magnitude is signified by these double absolute value looking things, and we're just going to multiply those two values together. Magnitude means the same as distance. So on the top, I'm going to put my vectors for v and u. Doesn't really matter what order. And then on the bottom, I'm going to have two distances. So the top, we already said the values were negative 5, 5. Nope, negative 5, negative 5, sorry. And negative 4, 1. Now we have to find the magnitudes. So for u, let's find the magnitudes over here. Remember, magnitude's the distance. That's going to be the distance formula. So magnitude of u is negative 5 squared plus the other negative 5 squared. That's going to give me 25 and 25, which is 50. Now, a lot of you want to reduce this. No need to reduce because we're just going to be typing it in the calculator and multiplying it by another number. So we will avoid the possibility of maybe making a mistake. So let's just leave that as square root of 50. This other one, let's find v's magnitude. So I've got v equals, and then the square root. Remember, v was negative 4, 1, so I'm going to put negative 4 all squared, and then 1 squared. This gives us the square root of 17. So the magnitude of v is the square root of 17. And I don't know why I didn't put my little magnitude bars here, but I should have. There we go. Now I have the cosine of theta equals, let's do the top numbers. That is 20 plus negative 5, so 20 minus 5 is 15. And then 50 times 17 is going to be 850, still under the square root. Alright, now that we have all that, I'm going to go ahead, hit inverse cosine, or second cosine, 15 over the square root of 850 on my calculator. And that's going to give me 59.036. If you got some tiny number, go back and make sure that you're in degrees mode and not radians. So, my final step is to look at this and see if this answer makes sense. Does this look like a 60-degree angle to you? It does to me, so that's good. Next, we're going to do the projection of u onto v. Remember, the formula for this is a lot of v's. We've got the dot product of u and v on the top, dot product of v and v on the bottom. This will be our scalar, and we'll multiply by vector v. So I'm going to do a little bit of estimating here, and I'm going to pretend that I have some sort of solar panel right here, or something that's parallel to the floor. We're going to consider v the floor, and everything's going to be shining upwards. I don't know, maybe the ceiling, who knows. But anyways, we've got light shining this direction toward the v, and this vector u is going to create a shadow. So if I were to draw a shadow here, I would say that u probably goes from here, I don't know, let me draw a little perpendicular line before I do this so it's not a terrible mess. So if I had to draw a perpendicular line to this, I would say that looks about right. Something in here maybe? That looks like about a 90-degree angle. So I'm going to say that if I were to draw a shadow, it would probably go from here backwards. Alright, so the vector I'm looking at is probably something like this. So if I were to have to estimate this, remember, putting it in component form would just be pretending this is 0. It looks like my y value is almost 1. So let's say, like, I don't know, 0.8, 0.9, somewhere between there. I'm going to guess about 0.85. And then from here it's going left 1, 2, 3.5-ish. So let's say negative 3.5. Okay, so this is my estimation of what the answer is going to be for this projection, this vector right here, this black one. So I'm hoping that my answer will be close to this. This is just a way to check our answer. Alright, let's see if we got it. So let's go up here. We've got two dot products to worry about. And then vector v will go here. So dot product on top and bottom. Okay, let's go. So we said that vector u was negative 5, negative 5. And then vector v was negative 4, 1. So I'm going to keep copying negative 4, 1 over and over and over again. There they are. Alright, let's do our dot products on the top and the bottom. That negative 4, 1 is just going to be copied. Alright, negative 5 times negative 4 is 20. Negative 5 times 1 is negative 5. So I've got 20 minus 5, 15. I feel like we just did that. Then down here I've got 16 plus 1 is 17. Alright, now I'm going to distribute this scalar into that vector. So this is 15 17ths times negative 4. So that's negative 60 17ths. And then I have 15 17ths times 1, so that's easy, 15 17ths. So that, my friends, is the final answer. That's the projection of u onto v. Now, remember, we wanted to check to make sure that our answer worked. So let's go ahead and divide negative 60 divided by 17. And my calculator says that's about 3.5. Then 15 divided by 17, my calculator says that's about 0.9. So let's look back to what we estimated. Look at that, negative 3.5, and I had 0.9 here, 0.85 there. That is awfully good. So we are quite certain now that this is the correct answer, both because I've done this about 50 times and also because it matches with what it looked like it should have matched with. Alright, so that's a good review. Now it's time to learn something new. On we move to trig form of complex numbers. So now you will notice that this is no longer x and y. This is now r and I, which rhymes but is very different. So r is going to represent all the real numbers. I is going to represent imaginary numbers. This is probably the first time you've graphed imaginary numbers on a graph. This is going to be super simple, so if your head's already spinning around in circles, have no fear. -3, you would agree, is a real number. It's for real. And the 2i, that I means it's imaginary. So this would be the same as me saying, let's plot the point -3, 2. Makes sense? That's the real number, that's the imaginary number. So let's go left 3 and up 2. And there it is, left 3 and up 2. Alright, you go ahead, do these three on your own, hit pause, do those, and then come back. Alright, so for this one, you should have said it was the point 1, -4, that's there. This one, a little bit trickier. However, there is no real number, so I could put 0 plus, and then there's just one I there, so if you want to put 1, that's okay. So that's going to be the same as the point 0, 1, which is right there. Finally, I've got 4 and -2 squared of 3, so in my calculator I type in -2 squared of 3, and that's about 3.5 negative. So I went right 4 and then down 3.5. And that's all there is to that. Can you believe it? Yes, it really was that easy. Now on we move to absolute values. Absolute values is the same as finding like the magnitude of the vector, or in other words, the distance. So you'll notice that this is the same as the distance formula that we used to find the magnitudes of vectors. You're going to consider this to be like a vector. -3, 2 would be your vector. So if you want to think of it like this, that's great. Alright, so -3 plus 2i would be this point right here, and I can draw a nice little line to get there. Okay, so this would be kind of like our vector on the real imaginary graph here. So I'm trying to find the absolute value, which is the same as the magnitude, so the absolute value of a plus bi, or in this case -3 plus 2i, would give me the square root of -3 squared plus 2 squared. You're not putting in the I, you're just putting in the A and the B. This gives me 9 plus 4, which is 13. We cannot simplify the square root of 13 because 13 is prime, so that's all there is to it. Finally, we can check our answer pretty easily, so this line, we could tell that it's going to be longer than 3, because 3 would be if you went straight across. So it's going to be something slightly longer than 3. From 3, we dragged it up. So let's look at this answer. This answer should be slightly bigger than 3. And if you put square root of 13 in the calculator, you're going to get 3 point, I don't remember, something, maybe like 6-ish, something like that. 3.6, 3.7. So that is bigger than 3. So yes, this is a good answer. Moving on here, this is just kind of a proof to show you why this works, but we're going to multiply two vectors together very soon. But first, before we do that, let's talk about putting things into trig form. In order to put something into trig form, I'm going to take my a value, which is like the x, it's going across, and my b value, which is going up and down. My r is going to be the radius, kind of like a unit circle, but this isn't just going to be a unit circle, this is going to be any circle at all. So z is a plus bi. We knew that from the previous problems that we've done. Now instead of a, I'm going to put r cosine of theta. Well, where did I get that? Right here, I know that cosine is adjacent over hypotenuse, so that would be a over r. If I solve for a, I would just multiply both sides by r to get this yellow box. Over here, I know that sine is opposite over hypotenuse, so that would be b over r. Brr. Then if I multiply both sides by r, I would get b equals r sine of theta. So instead of a here, I'm going to substitute r cosine of theta. Instead of b, I'm going to substitute r sine of theta. Since they both have an r in common, I'm going to factor out that r in the front. So this thing right here, this is considered trig form of a complex number. R is on the outside. Remember, that's the distance or the radius. And then your cosine plus I sine goes inside. Now, if you ever see the word modulus, that means R. If you ever hear of an argument, either that's something going on at your house during the sequestering that we've had, or it could be talking about the angle or theta. We're going to write this complex number in trig form. Hey, it's not so bad. So one thing that you need to know is R. Another thing that you need to know is theta. In order to find theta, we're going to use tangent. Okay, so let's start off with R. We know what we're doing. We're taking the square root and doing the distance formula. That first number was 6. The second number is -6 up here. And then here we go. This is, hey, if you have the same number twice, my advice for you, if you've got the same number twice and they're added, this is 36, this is 36, I could take the square root of 36, which is 6, and put square root 2. If you're not sure how I did that, that's okay. 36 plus 36 is 72. 72 has 36 in it, so I can divide it out. A 36, the square root of that is 6. Alright, so I know that R is 6 square root of 2. Let's move on to tangent. Tangent is the y value, or in this case the I value, over the x, or in this case the real. Then, if it simplifies to a nice purty number like this one, go ahead and simplify it. Now, fortunately for us, we know the tangent of -1, or if we don't, we certainly should. So for those of you who are not familiar with the hand method, you take your left hand and spread out your fingers. So you're looking at the back of your left hand, spread out those fingers, and between your pinky finger here and your thumb, you should have about a 90-degree angle. So if we're talking about the angle between your pinky and your thumb, that's about 90 degrees, and in tangent world, that gives you an undefined tangent. Then, if we're talking about from your thumb to your thumb, that's 0 degrees, or 0 radians. That's going to give you 0 for the tangent. If I'm talking about pi over 6, that's going to be the square root of 3 over 3. Pi over 6, of course, the same as 30 degrees. Over here, this is pi over 3, which is the same as 60 degrees, and that is square root of 3. Here at flipper, the middle finger, this is 1. So if you remember those, that will make your life a lot easier. So here tangent is -1. We'll worry about the negative later, so let's talk about the tangent of 1. This is 45 degrees, or pi over 4. I'm going to go ahead and let's do this in degrees, just because I think it'll be less confusing for you. So swooshy, the reference angle, gives me 45 degrees. Next, I have to put this into the correct quadrant, because -6 is not in quadrant 1. 6 goes right, -6 goes down, so that would take us over here to quadrant 4. Hopefully you remember all my cool little sayings. Antelopes sometimes tackle children. This is in the 4th quadrant, like we said, because we went right and down. So in the 4th quadrant, I know that cosine is positive. That means that tangent is negative, which it is. And also, in this quadrant, I'm going to do 360 minus swooshy, the reference angle, to come up with my final answer. So my final answer for theta is 315 degrees. Alright, now I have theta. I have r. I'm ready to write this into trig form. So, like we saw right here, r is going to come first, and then cosine plus I sine of theta will go next. So let's go back to it. R goes first, 6 square root of 2, and on the inside we've got cosine plus I sine, not to be confused with an iPhone, and then here we're going to have 315 for both. And that's all there is to that one. Moving on, we're going to do the exact same thing, but we're going to do it backwards. And this time it's in Radians mode. I know that because there's no degrees here, and also another clue is there's a pi. Fortunately, you will not need your calculator for this, so have no fear. Oh, I almost forgot to tell you something. Hey, if you wanted to check your answer, it is so easy to do. If you want to check your answer, bust out that calculator. Multiply these through. So if on your calculator you multiplied 6 square root of 2 times cosine of 315, you type that all in, your answer will be 6. And then you do 6 square root of 2 times just sine of 315, and that answer gives you negative 6. Don't forget to write down your I. And you will recognize this from right here. It will give you the same answer you started with. So it's a great idea to do that. It only takes a few seconds and the calculator does all the work. Okay, now we have writing the complex number in standard form. Right now it's in trig form, and we know that because we have trig functions. Just like we did to check that previous answer, we're going to multiply this through. But before we multiply, let's go back and find the cosine of 2 pi over 3 and the sine of 2 pi over 3. So I'm going to copy that 8 down. I'll have a plus sign, and I know there will be something with an I over here. So cosine of 2 pi over 3. I know that 2 pi over 3 has a reference angle of pi over 3. So what's the cosine of pi over 3? Well, first we should probably go back here and remember that aardvarks sometimes taste crunchy. Let's look at which quadrant 2 pi over 3 is in. 2 pi over 3, 1 pi over 3 would be here, 2 pi over 3 would be here. So sine is going to be positive. Cosine, therefore, will be negative. Alright, 2 pi over 3 is the same as pi over 3 as far as we're concerned, except there's a negative sign in front. So what's the cosine of pi over 3? You should be flicking up your ring finger right now. That would give me 1/2. Next, sine of 2 pi over 3. Same thing as sine of pi over 3. Again, ring finger gives me square root of 3 over 2. Finally, distribute through your 8, so z is going to be negative 4, because 8 times negative 1/2 is negative 4. 8 times square root of 3 over 2 is going to give me 4 square root of 3. And then, I almost forgot my I. Don't forget to put an I. Now, your book always puts the I at the end right here. Oh, a lot of my professors would have said, no, you don't want to write it like that because it looks kind of like the I is under the root. It looks kind of wacky. So you would write it like this. However, your book writes it like that. So, just in case you're wondering, if you happen to have an I and you think it's under the square root for this entire course, that will never ever happen to you. So remember that the I is always on the outside of the square root for this entire course. Alright, moving on. This is a cool, huge, long proof showing you two vectors or two of these in trig form multiplied together. I multiplied using FOIL, I combined like terms, I got some beautiful stuff, and this ended up being my final answer once I simplified everything. This is just to show you a long proof of how we figured out these formulas right here. This was the product formula that I just showed. There's also a quotient formula with a very, very similar proof, and then a power formula, also known as de Moivre's theorem, for those of you who speak French. You can write it either like this first one or the second one. Me personally, I always use this one. Now let's put them in use. Here we go. I'm going to find z1 times z2. In order to do that, first I need to know what r is, and I'm going to have two of them since I have two vectors. I also need to know what theta is, and again I'm going to have two of those since I have two different vectors. So for vector number 1, my r is 3, because this is in trig form, the number on the outside is always r. My theta is pi over 3. Alright, not too bad. R2 is 4, and R2 is also D2's friend. Thank you so much. Pi over 6 is going to be my angle. Okay, So now let's take R1, which is 3, and it's touching the R2. That means they're multiplied. Here I have cosine, and I'm going to add my two angles. So I've got pi over 3 plus pi over 6. And then I'm going to do plus I sine of the exact same angles added together. Just like that. Now let's simplify as far as we can. 3 times 4, that should be easy. That gives us 12. Here I have cosine of. Now if you stink at fractions, good news, your calculator will do this for you. All you have to do is type in 1/3, no pi, 1/3 plus 1/6, because there's a 1 pi here. So 1/3 plus 1/6 gives me 1/2. If you've got the TI 84 or 83, you did 1/3 plus 1/6, math, enter. Alright, so this gives us 1/2, which is 1/2 pi, or pi over 2. Uh-oh, calculator freezing. Computer, come on. There we go. Alright, so we have cosine of pi over 2 plus I sine of pi over 2. Let's now think of what pi over 2 would be. Alright, cosine of pi over 2 is right here. We remember x and y goes with c and s. If you're in my class, we know this as colorful snot. Colorful snot. So c is going to be cosine, s is going to be sine. The x value here for this point is cosine. This would be the point 0, 1. So my cosine here is 0. Or you could just use the pinky finger on your hand. Over here I've got the sine of pi over 2. Sine is the same as the y value. That is 1. So I've got a 1 there. Don't forget to copy your I. Now that I have that, I can go ahead and distribute through that 12. I personally like to keep the 0 there. Even though you don't really need it, go ahead, keep it there. And then 12 times I is 12i. I keep the 0 there just in case I have to graph this point. If I have to graph the point, that way I know that it's the point 0, 12, and I don't accidentally go the wrong direction, 12. Alright, so that's it. That's the answer in standard form. Now let's do the same, but let's do division. This time there is no r in front of that, or that one, so they're both 1s. So r1 is 1, and r2 is also 1. Now let's do theta. The first theta was 40, the second one was 10. Alright, pretty easy. I think you've got this. Hey, you know what? You probably could solve this whole darn thing. Go ahead and hit pause and then see if you can work this out. Alright, now we're back. Hopefully you have 1 over 1 here because that's our r1 and r2. Then I have cosine of 40 minus 10 degrees plus I sine of the exact same thing. Okay, next I have 1 divided by 1 is 1. Then the cosine of 30 degrees plus I sine of 30 degrees. Now I know technically I don't need that 1 there, but I'm going to leave it there just for practice. Cosine of 30 degrees, that's your pointer finger, that's square root of 3 over 2. Sine of 30 degrees is 1/2. Now again, I know if I distribute 1, I'm going to get the same thing. I'm just leaving the 1 there just to show you what would happen if it were a number other than 1. I'm going to distribute the 1 through. That gives me square root of 3 over 2 plus 1/2 I. And that's it for that one. Now let's do the power theorem. This is when you have to find something to a certain power. So again, we're going to find R1 and R2 and theta 1 and theta 2. But looking at this, it looks different. What am I to do? This is in standard form instead of trig form and trig form like we've had for the past two. So I probably need to find all of this information just like I was going to put this into trig form. So to do that, let's go ahead and find r. Remember, r is the distance formula, same as the magnitude, so I'm going to do the distance. There we go. Remember, we're not putting I in there. We're only using A and B, not the I. So remember, if I have a square root being squared, the square and the square root will cancel. So this is really the same as 1 plus 3, which is the square root of 4, which is 2. So I know that r equals 2. Now let's find theta. To find theta, we remember that tangent of theta equals, well, it equals, hopefully you said, square root of 3 over negative 1. Alright, now that I have that, I can simplify it. It's just the square root of negative 3. Next, I'm going to try to think of my tan hands. Remember that cool little drawing I showed you just a little while ago? Where was it? Where the heck was it? There it is. Here's my tangent hand. And hopefully you would say that the square root of 3 is up here at ring finger. That's going to be pi over 3. So I'm going to let this be pi over 3, or if you prefer, 60 degrees. Most of you prefer degrees, so I'm going to stick with 60 degrees here. Since this is in quadrant 1, however, this is not quadrant 1 because this goes left because it's negative, this goes up, that would be quadrant 2. Quadrant 2 is here. Tangent should be negative here, which it is, so that's a good sign that I chose the right one. And in quadrant 2, I'm going to do 180 minus the 60. So my theta is equal to 120 degrees. So I have my theta, I have my r. Now, you'll notice this one is a little different than the previous ones. I had set it up originally with an r1, r2, theta 1, theta 2, but that only happens for these. Those are the only ones with two different ones. This one does not have a 1 and 2 because it's just squared, so it's being multiplied by itself. Or in this case, it's not squared, it's actually to the 12th power. So I don't really need an r2 or a theta 2 for this one. Alright, so we said that r was 2. We said that theta was 120. Now, the one letter or variable that I have here that I didn't before is n. N is just whatever my exponent is. So in this case, that would be 12, right there. Now that I have those three letters figured out, I am good to go. So here we go. R, which is 2, to the n, which is 12, cosine of n, which is 12, times 120, plus I sine of the same thing. Alright, this is a mess. 2 to the 12th power, let's simplify. 2 to the 12th power is going to give me 4096 if I remember correctly. And then cosine, oh my goodness, this is a huge number. What is this? This is the cosine of, I have no idea. So let's multiply these on the calculator. That's going to give me the cosine of 1440. Whew, that's a big number. Plus I sine of the same thing. Now, I'll tell you a secret. If we had done this in radians, our lives would have been a lot easier. In radians mode, this would have been 8 pi. So, I would have just subtracted 2 pi from it until I got some answer between 0 and 2 pi. For this one, I'm going to keep subtracting 360 until I get an answer between 0 and 360. So, go ahead, keep subtracting 360 from it over and over again, and after you do that, you should get 0. So both of these are 0 degrees. Next, since this is a nice pretty number and we know the answer for it, let's go ahead and figure out the answers. What is the cosine of 0 degrees? Hopefully you said 1. The sine of 0 degrees is 0. So I multiply that through, oh, and that's the same as 0i. I multiply that through, so that's 4096. And you could leave it like that, but I like to put in the I just in case. And there you go. So that's De Moivre's theorem. Finally, we're going to find nth roots. So this would be like square roots, cube roots, whatever roots you like. Now, your book is going to show this a little bit differently. I like this shortcut instead. So the book method is a little bit tougher, and I really think you're going to like this shortcut much better than what the book has. So what I do is I find the first root in my list. I have to first know my r and my n and my theta, just like I did with the other ones. But this time I'm going to plug them into this formula here, and then I'm going to have more than one answer. So for example, square roots have 2 answers, cube roots have 3 answers, fourth root have 4 answers, and so on. So all I'm going to do is find that first answer, and then my angles here, I'm going to continue to add something which I just call the increment formula. I'm going to keep adding an angle each time to the original angle. This doesn't make sense to you yet, but it will soon. Let's do one together. Now, something you don't want to see up here is a big number like this one. If you have a big number, that means you're going to have that many answers, remember. So if it's the 6th root, you're going to have 6 answers. If we have a cube root, that's 3 answers, and so on. Alright, so here we go. 1. Well, 1 is the same as 1 plus 0i. Or we're going to think of this in vector form, that would be 1, 0. So just like we talked about, we're going to find our r value. R here is just 1 squared plus 0 squared, so that would give me 1. Alright, that one was easy. Now let's go to theta. In order to find theta, I'm going to do tangent of theta equals the y value, or in this case the imaginary value, over the x value, or here the real value. 0 divided by 1 is 0. Next, I'm going to figure out where is tangent 0. Well, good news. Tangent of 0 is 0 at 0. There we are. Now I have theta. I have r. The last thing I need is n. And good news, n is always given to you. It's the number of roots. So n here is going to be 6 for 6th roots. And that's all we really need. So I'm going to go back. I'm going to copy this and paste it, just so you can see what I'm doing. I'm also going to shrink it because we're going to need the room. This is going to be one of those where you're thinking, why did he make this only 1 square? Alright, here we go. Nth root of r, that means 6th root of 1. 6th root of 1 right there. Then I'm going to write my cosine plus I sine. I'm going to fill this in. Theta we said was 0 degrees. N we said was 6. So I've got 0 over 6. Beautiful. Okay, so that is what I consider my setup. Once I have the setup, now I'm going to write this 6 more times. Oh, and before I do, in this case, we can actually 6th root 1. It's pretty easy to do. So go ahead and take the 6th root of 1. That's just 1. So we're going to write that 6 times. 1, 2, 3, 4, 5, 6. Okay. Now, usually this is not going to be easily rootable, so we would just copy it over and over again. Since this one had an easy root though, we went ahead and took it. Next, I'm going to draw my parentheses, and inside those parentheses, I'm going to keep writing the exact same thing. Cosine of blank plus I sine of blank. Just like this. So go ahead, copy that 6 times total. Hopefully you can do that at least as fast as I can with the pen pad. Whew, okay, there we go. So now that I have all of that stuff, I'm going to go ahead and put in my first angle. So 0 divided by 6 gives me 0. Now this angle won't normally be 0, just happens to be the angle this time. Alright, so I have 0 and 0. That's my first angle. All I did was I simplified the setup. So once you have that first one, that's your answer in trig form. Now what I have to do is I have to take each of these angles, the zeros, and I'm going to add my increments. Now I haven't done the increments yet, so I should probably do that now. Using my increment formula is 360 degrees divided by n. So in this case, it's 360 degrees divided by 6. So my increment is 60 degrees. Alright, so I'm taking that 0 degrees and I'm going to continuously add 60 degrees more to each previous answer. So 0 plus 60 is going to give me 60. Now, I'll tell you the increment is not normally the number that you see here. For example, if this number had been 10, I would have added 60 to 10, and that would have given me 70. Alright, so the increment is not normally the number here, but it will be if the original angle was 0. That's the only time that'll happen. Alright, so I'm going to add 60 more to 60, and then add 60 more to that. It's 180. Add 60 more to that, 240. Add 60 more to that, that takes us to 300. And if for some reason I went crazy and kept going and added 60 more to that, that would have given me 360 degrees, which would have given me the same answer as 0 degrees. So I would have repeated answers again when I put it in standard form. Alright, so those are all of your answers in trig form. If the question asked you for all the answers in trig form, you would be completely finished. If, however, I also asked you for the answers in standard form, let's put ST and D for standard form, you would have to continue going. So, if this were an ugly angle, I would go ahead and just do this all on the calculator. Since this is a pretty angle, and I know the cosine and sine of this angle, I would go ahead and multiply it through and figure out these values in my head. So the cosine of 0 is 1. 1 times 1 is 1. The sine of 0 is 0. 1 times 0 is 0. Now, looking back to what the question asked us, find all the 6 roots of 1, you were probably thinking to yourself, well, the 6th root of 1 is just 1, right? Well, that's true. The 6th root of 1 is just 1 plus 0i. However, there are 6 more answers, or 5 more answers, when you think of this in terms of imaginary numbers as well. So the cosine of 60 degrees is 1/2 times that 1. The sine of 60 degrees is square root of 3 over 2 times that 1, which is the same. So this is also a 6th root of 1. Next, the cosine of 120, this time is negative 1/2 times 1. And the sine of 120, this is quadrant 2, so sine is positive. The cosine of 180, this is directly on the x-axis, so you went left 1 and up 0. Cosine of 240, this is in the third quadrant, so both of your answers are negative. Remember, 240 has a reference angle of 60, so it's the same answer as this one, except both are in the third quadrant, so they're both negative. This is in the fourth quadrant where cosine is positive and sine is negative. Again, they both had a reference angle of 60, which gave me the same answer. Alright, those would be your answers in standard form. Now, a simple way to check this answer would be to go ahead and plot the points on a graph. So there are my 6 points. I plotted them all on this graph. And what do you notice about those points? Well, they should be very evenly spaced apart. So if I created vectors with all of these, like this, this is not going to like me. Alright, there's one, there's another. What do you notice about all of these angles that are being created? So think of this as slices of pizza. What do you notice about all the slices? Well, if I graphed it pretty decently and it's on a square grid like this one is, all of my pizza slices should be basically the exact same shape and size. So all of them should have the same angle on the inside. And what angle do you think this is on the inside? Well, hopefully you were thinking back to my increment formula of 60. So I took my whole circle and I cut it into 6 slices, making each of these 60 degrees. So you would agree that's 60 degrees. All of them here are 60. And if I added all the 60s together, that would give me 360 degrees, which is a circle. Alright, so again, a great way to check your answer is to plot all the points. They should make a beautiful circle, and they should all be evenly spaced apart, with your increment being the angle between each one. Alright, let's do one more just to make sure you are A-okay. This time I'm going to be nicer to you. I'm going to do cube roots, so n is going to equal 3. Go ahead, hit pause on your own, find r, theta, and the increments. Okay, hopefully you have paused and you figured out that negative 6 squared plus 6 squared is the square root of 72. Now when we did the same problem before, I had you go ahead and reduce that. However, this time I'm not going to reduce it, and I'll show you why in the end. Next, I'm finding the tangent of 6 over negative 6. That's the tangent of theta equals negative 1. Sorry, I forgot my theta. So where is tangent equal to 1? Hopefully you would say that's 45 degrees. But this is not really 45 degrees because I was going left and up. So in quadrant 2, I know that theta is 180 minus 45, or 135 degrees. So I have r, I have theta, I know what n is because that's way up here. For the cube roots it's 3. Finally I'm going to do my increments. My increment, remember, is 360 divided by n. And here was 3 because of the cube root. So my increment is going to be 120 degrees. I have all the information I need, so let's go ahead and paste my cool formula and shrink it down a bit. So here we go with our setup. The nth root, cube root, of r. R was the square root of 72. I have a cube root of a square root. Don't panic, we'll fix that in a minute. Cosine of theta is 135 over n was 3. And then I sine of the same thing. Beautiful. Okay, next we're going to simplify this as far as I can. Now, I have a cube root of a square root, which is probably freaking you out. So, cube root of a square root of 72. Now, square roots, we don't normally write this, but let's go ahead and put that 2 there for square root. We normally just leave that blank to assume that it is a square root, just because math people are sometimes lazy. Alright, let's write this in exponential form. So if I had to write the square root of 72 with an exponent up here, I would put 1/2. Remember, the number on the bottom tells you the root. So this would be the square root of 72. Now if I had to take the cube root of that, a cube root would be 1 over 3. You know that when exponents touch each other, they're going to be multiplying each other. So with 1/2 times 1/3, that's going to give you 1/6. So putting this back into root form, this would be the same as the 6th root of 72. Or more simply, you can think of it as the 2 and the 3 multiplying together because they're touching to become that 6. So this is going to be the 6th root of 72. This is the whole reason why I didn't try to simplify it, because this is a lot easier to look at than roots within roots. So right here, I'm going to change this to the 6th root of 72. Now, that was my setup. Now I'm going for my 3 answers. So this is the 6th root of 72. I'm going to write this 3 times because this was cubes. Even though this is the 6 here, doesn't matter to me. All I care about is what n equals. So since n equals 3, write it 3 times. Draw your little parentheses, cosines, and plus I sine. Now there is kind of a shortcut way to write this. You might see somewhere, some places have CIS here and then just one angle written. I don't like doing that to you because it confuses a lot of people. But if you want to, inside the parentheses here, you could write CIS, which stands for cosine plus I sine, CIS, and then the angle. It means the same thing, but again, it normally confuses people, so I don't do it. Alright, my original angle was 135 divided by 3. Looking at my calculator, it says 45. So 135 divided by 3. After that, I'm going to take my 45 and add my increment to it. So that's going to be 45 plus 120. That gives me 165. And then 65 plus another 120 is going to give me 285. So those are the answers in trig form. As usual, I'm not so nice to just leave it as trig form. I'm also probably going to ask you to put it in standard form. However, this one, good news, we don't know the 6th root of 72. At least I don't off the top of my head. So these are all going to be in decimal form, which means the calculator will do all of the work for you. So all you have to do is first make sure you're in degrees mode because we have degrees, then multiply the 6th root of 72 times cosine of 45. Now, if you've forgotten how to find something crazy like 6 roots, what I typically do is type 1/6 in parentheses and hit equals. However, some of you really like using roots and don't like exponential, so what I would do is hit 6 on your calculator, then hit math, and you should be able to go down. The 5th option, at least in my calculator, the 5th option has something that looks like this. That's the one you want. So you press 6, then that thing by hitting math, and 5 is my option. Your calculator may be different, but probably close to the same. And then you're going to type in that 72. So 6, that thing, and then 72 equals, and that should give you what you're looking for. Alright, so let's get rid of that. Great. Okay, so on my calculator, I'm multiplying again. 6 root of 72 times cosine of 45. My calculator gave me 1.442. I did the same thing with sine. That also gave me 1.442. Don't forget your I for the second value. This one gave me negative 1.970 plus 0.528. Don't forget your I. And finally 0.528 minus 1.970. Don't forget the I. And those would be your answers in standard form. Don't forget the N. Alright. Hopefully you're feeling good. Sadly, that is the last slide that we have for today. I hope you are all doing well, staying healthy, staying home, and if you have any questions, you know where to find me. My email address is there on my Canvas page. Also, you could go to my office hours. My office hours also listed on my Canvas page. We could do a Zoom chat, and I can answer any questions that you have. Finally, your homework is also on my Canvas page, so check that out. Again, I hope you're all doing well. Let me know if you need anything, and we will see you again soon. Goodbye, everybody.